Hey guys, in today's problem, we are given two square matrices called mat and target. Both matrices are of size m by n, and they contain only binary values, which means each cell is either 0 or 1. Our task is to determine whether we can make the matrix mat equal to the matrix target by rotating mat. The rotation allowed is only in 90-degree increments. This means we can rotate the matrix by 90 degrees, 180 degrees, or 270 degrees. We can also choose not to rotate at all, which means 0 degrees. After each rotation, we need to check if the matrix mat becomes exactly equal to the target matrix. If at any rotation mat matches target, we return true. If none of the rotations result in a match, we return false. So in simple terms, we are checking whether the target matrix can be obtained by rotating the original matrix in steps of 90 degrees. Let's understand these examples step by step. First example, the input matrix mat is 0, 1, 1, 0. The target matrix is 1, 0, 0, 1. Now we try rotating the original matrix. If we rotate mat by 90 degrees clockwise, the rows become columns. After rotation, the matrix becomes 1, 0, 0, 1. Now, this exactly matches the target matrix. So since we are able to make mat equal to target with one rotation, the output is true. Second example, the input matrix mat is 0, 1, 1, 1. The target matrix is 1, 0, 0, 1. Now let's try all possible rotations. First, check without rotation. The matrix does not match the target. Next, rotate by 90 degrees. The matrix changes, but it still does not match the target. Then rotate by 180 degrees. Again, the matrix is different from the target. Finally, rotate by 270 degrees. Still, it does not match the target. Since none of the rotations make mat equal to target, it is not possible to achieve the target matrix, so the output is false. Third example, the input matrix mat is 0, 0, 0, 0, 1, 0, 1, 1, 1. The target matrix is 1, 1, 1, 0, 1, 0, 0, 0, 0. Now we need to check if we can make mat equal to target by rotating it. First, check the original matrix without any rotation. It does not match the target. Now rotate the matrix by 90 degrees clockwise. After one rotation, the matrix changes, but it still does not match the target. Now rotate again by another 90 degrees, which means a total of 180 degrees. After the second rotation, the matrix becomes 1, 1, 1, 0, 1, 0, 0, 0, 0. Now, this exactly matches the target matrix. So since we are able to match the target after rotating the matrix 2 times, the output is true. This example shows that we may need to try multiple rotations before finding a match. We are given two matrices, original matrix and target matrix, and both are square matrices. The idea is simple. We try all possible rotations of the original matrix and check if any of them match the target matrix. Let's walk through the code. We use a loop that runs 4 times. This is because a matrix can have only 4 possible states when rotated in 90-degree increments: 0 degrees, 90 degrees, 180 degrees, and 270 degrees. Inside the loop, the first thing we do is check if the current state of original matrix is equal to target matrix. If they are equal, we return true immediately. This means we found a rotation where both matrices match. If they are not equal, we rotate the matrix by 90 degrees clockwise. Now let's understand how the rotation works. The expression original matrix reversed using slicing flips the matrix upside down. Then we use zip with unpacking to transpose the matrix. Transposing means converting rows into columns. Finally, we convert each row into a list to get the rotated matrix in the correct format. This combination of reversing and transposing results in a 90-degree clockwise rotation. After rotating, we go back to the next iteration and again check if the matrix matches the target. If after all 4 rotations we do not find any match, we return false. This means it is not possible to make the original matrix equal to the target using rotations. Let's run the solution and execute it successfully for all the test cases. After testing the solution with different cases, we submit the code. The solution passes all test cases successfully. That's it for this problem. We solved it by checking all possible rotations of the matrix and comparing each one with the target. This is a straightforward and reliable approach for matrix rotation problems. Make sure you hit the like and subscribe to the channel, and please find the solution link in the description. See you in the next video with another daily LeetCode solution.